Well, welcome back. We've got another great review tonight for our AP Calculus exam coming up just around the corner here. And tonight's focus is on volume. There's actually two topics tonight. The first one we're going to hit is volume by revolution. Okay, so we're revolving something around a line or an axis. And the second one is volume of solids, aka known as your cross sections. And this is what our big project is on. So let's start with a quick review. Last night we reviewed area and we kept saying keep it simple. Area is your most simple form. Area is strictly just the integral of that upper minus lower. dx, of course, or dy, depending upon what you're talking about. It would be right minus left if we said dy. Okay, I want to stress in area there are no pi's and there are no squares. All of that comes into play with volume. Okay, so area again was our focus last night. Tonight, we said we're going to focus on our revolutions, and you have the option to choose a volume by a disc or a volume by a washer. Now, there are other methods out there, but these are the two we focused on this year. So what's the main difference? Well, a disc, if you look at my shaded region here as you're drawing it in your notebook, this shaded region is strictly on my axis of revolution. It says the horizontal axis is the axis of revolution. There is not a single gap between the shade and that line. Okay, that makes it a disc. Versus my second drawing here, notice I'm revolving, here's my revolving symbol around this x-axis, and there is a gap between my shaded region. Okay, now even if half of my section was on this axis, if there's any gap at any moment in time, you've created a washer. So what's the difference between the two formulas? Well, check them out. They both start with pi, integral a to b. They both have a big R squared. The only catch is if it's a washer, you have a second radius. So our washer formula is pi, integral a to b, big R squared minus little r squared, versus, the disc, which is just pi a to b of r squared. So very, very similar, disc and washer. One just has that extra radius. Example 1. Now I know I wrote find in all of these. We are literally just setting these up. We're not going to go through and evaluate. You should be pretty good at that part by now. Our goal is to focus on the setup. Let R be the region in the first quadrant bounded by the graph y equals 2 radical x, the horizontal line y equals 6, and the y-axis. So they've already gave you the picture and shaded it in. It's not going to get nicer than that. Okay, so now it's our job not to screw this up. Part A, the key buzzword is area. So I'm saying to myself, keep it simple. There is nothing fancy. It is strictly upper minus lower. Now, how do you do that? Well, you go to your shaded section, the section they described, and you draw in a vertical slice. Okay? Every picture should have a vertical slice. I put an endpoint on this one and one on this end. Every time. And I literally say who's on my upper and who's on my lower. So I'm going to say it's the integral of the upper was this line, 6, and the lower is 2 radical x. So it should be upper in parentheses minus the lower in parentheses, dx. Again, keep it simple. No pi, nothing squared for area. Now I need bounds, so I say, once I draw my slice in, is the area to the left and the right, or is the area above and below? Well, clearly, I think anybody can see there's area to the left and there's area to the right. So I'm looking for the leftmost point and the rightmost point. So if I go all the way to the left, that's at a 0. And if I went all the way to the right, that number is 9. So I'm saying 0 to 9. Okay, part B. Find the volume, again, setup only, when R is rotated around the line y equals 6. So again, this section is not changing. It's still the shaded section. You've got your slice drawn in already with the 2 dots on the endpoints. Now you draw in the rotation line, y equals 6. And I'll do it in red here. Here's, y equals 6. Now what is special about my shaded section to that line? Is this a disc or a washer? Is there any gap between the shaded section, and you want to make sure you shade in your own picture, and the line? No. So that makes this a disc. So again, I think you're crazy if you don't start with the formula. Volume equals pi a to b big R squared. Okay, now, what the heck is big R? Well, there's a reason you put those 2 endpoints on. Okay, I'm still saying upper minus lower. Okay, it goes back to your area idea. Keep it simple. It's upper minus lower. So volume equals pi, the integral. I'll get my bounds in a minute. The upper, go to the upper dot, is sitting on 6. Minus, go to the lower dot. That's why we put dots there. 2 radical x. And that represents your r. Now in this case, you're going to take all of that and simply put a big squared around it. Okay, so it's pi, big R squared. Now again, I need those bounds. So I'm saying, where's my area? Well, there's area to the left and area to the right. That means how far to the left can I go and how far to the right can I go? So hopefully, again, you've said 0 to 9. Part B, C. Find the volume when r is rotated around the line y equals 10. So I'm going to slow down and I'm going to draw in that line y equals 10. Let me get my purple pen here. I'm going to draw it way up here. Y equals, 10. Okay, now look at your shaded section. Nothing is changing. Is this shaded section touching the new rotation line? Of course not. That now makes this question a washer. So again, let's get our formula down. Pi, integral a to b, almost the exact same as a disk, but it's big R squared minus little r squared because I'm going to have 2 radiuses. So where do those radiuses come from? Again, it's all about your drawing. I'm going to go from one of the dots I drew on my original line to the rotation line, and then the other dot to the rotation line. Okay? So, Devin, if you're paying attention here, you'll want to make sure you go from this dot and this dot to the rotation line. That's why I'm stressing, draw those dots. Alright, so I'm going to go pi. Again, my area is to the left and the right. That has not changed, 0 to 9. Now I need my big R. So I'm going upper minus lower. This R is bigger than this R. The upper one is on 10. The lower is on 2 radical x. 10 minus 2 radical x. There's big R squared. Now I need little r. So I go to my rotation line, and I go from the upper to the lower of that bracket. 10 minus 6. Can you do the math in your head? Of course. I'm just going to write it out for everyone to make sure we're on the same page. And then from there, I'd FOIL, clean it up, and evaluate my actual integrals. All right, let's get a second example in here. So go ahead and draw it for yourself. And the figure above, R is the shaded region in the first quadrant, bounded by the graph y equals 4 ln of 3 minus x, and the horizontal line y equals 6, and the vertical at x equals 2. Find the area of R. Now, it's not telling me if I have to go perpendicular to the x or the y, but x is always easier, so why not start there? So I'm going to draw in one slice with my dots on the end, and I'm going to say, okay, is this one slice good enough? Is this always on the top, and this one always on this curve? I would say yes. So I think my area is going to be very, very nice. Area equals, remember, no pi's, no squareds, the integral of my upper minus lower. My upper is on 6 minus my lower, which is on 4 ln of 3 minus x. And we're done with area. Upper minus lower. Areas, keep it simple. B, find the volume when rotated about the y-axis. Now, oh boy, do I hate to see the y-axis. Okay, because right now, look at your slice. This slice is perpendicular, okay, makes a T with what axes? It's going to make a perpendicular with the x-axis. And that's when life is good. It stinks when I have to be perpendicular to the y. Are they going to throw it at you? Of course they are. All right, so even though it stinks, we just got to go with it. So this slice here is no good. All right, so I'm actually going to resketch this picture to attack part B here because I know it's super annoying when I have to go to that y-axis. So I would do the same in your notebook there, copy it down. Let's go ahead and draw our slice in perpendicular to the y-axis. That's our new rotation line. And again, once you draw that slice in, make sure you put your 2 dots on the end. Now the question is this one slice good enough for the whole picture? And what do I mean by good enough? Well, is this dot always on the right side? And is this dot always on the left? Well, no, because as this dot moves up, eventually this becomes the left. So no, I would say this is not good enough. And my good friend might call this savage here. So I would definitely say this is a savage problem. So I'm going to go ahead and draw two different slices. Now, what do I have to catch off this? Well, let's slow down here. I've got one that's a disc and one that's a washer. Can you tell the difference? If I box in this bottom half and I look at the shaded region compared to the rotation line, there is a gap. So I want to be clear, this piece is a washer. But if I look at my top half and I look at my shaded section and my rotation, do you see how it's all touching? That piece is a disc. So you actually have two pieces to the problem here, a disc and a washer. So let's go ahead and start with the easy one. I think the disc is a little easier. So I'm going to write down disc for myself, and I'm going to write my formula down. Volume equals pi big R squared. Okay, now it's very similar to the washer formula, remember. So pi, okay, let's talk bounds. So first of all, if I look at my slice, is the area, shaded area, to the left and the right, or above and below? Well, I hope it's obvious. It's above the line and below the line. So those are my bounds, how high and how low it goes. Well, it looks like it goes up to a height of 6, and down to a height, I'm not 100% sure, so we'll find that in just a moment. Okay, now I got to figure out how tall this graph is. Well, all I have to do is say, okay, however tall 0 is here is how tall that function is. So if I go to 0 and I plug that in my equation, y equals 4 ln of 3 minus x, I get 4 ln of 3. So that is how tall that function is there, 4 ln of 3. And I'm going to say right minus left. So you'll notice the right side is on the line 2, and the left side is at 0. So it truly is 2 minus 0 squared. Now be careful, there's no variables here, but you went horizontal, which means you need a dy. Now we're not done, because we're also going to have to add on this washer piece. So let me start with the washer formula. So washer looks almost the same, it just has two r's. Volume equals pi big R squared minus little r squared. Okay, so I'm going to draw in my rotations. So I'm going from one dot to the rotation line, other dot to the rotation line. The big one is called big R, the little one is called little r. So I'm going to add on pi. Let's talk bounds. Again, the area is above and below, so it can go all the way to the bottom, which has a height of 0. You go all the way to this red line here, or black line, which has a height we already know of, 4 ln of 3. Alright, so let's get big R. I need to say it's the right side, right end, to the left end. So this is on 2, this is on 0. My big R is 2 minus 0 squared. Minus, now I need my little r. This one is on the curve, I already forgot the name of the curve. 4 ln of 3 minus x. And then its left side is touching 0. Now what's the problem with that? Well, remember, everything has to be in terms of y. We said this is the annoying part. So I have to resolve this equation so it's in terms of y. Right now it's in terms of x because x is the variable in the problem. So hopefully your gut says first divide both sides by 4. Now some people like to use their log properties and move this up to the top, but I think you're just making your math uglier. Truly, just divide by 4 to get rid of it. So I have y over 4 equals the ln of 3 minus x. Now I can use exponentials to get rid of that. So I'm going to say e to the y over 4 equals the ln of 3 minus, oops, no, we got rid of the ln, of 3 minus x. And then I'm just going to solve for x. So I'm going to basically add my x over to this side and take this and move it to that side. So I'm going to say x equals 3 minus e to the y over 4. And that is what my right side will be, that curve minus 0. So 3 minus ey to the y over 4 minus 0 squared, and then again dy. So maybe not the prettiest, but that is the entire setup for that volume equation. So welcome to the second part of tonight's video on solids, volume of solids, also known as cross-sections. And this is what your project is based on that's coming up. And remember, you have till May to get this done. So I grabbed a snapshot of three very simple ones. I'm going to start with the one on the right. Clearly they chose rectangles. So when you choose rectangles, or if you choose rectangles for your project, you'll just have to make up the rule. The height equals half the base. The height equals 3 times the base. Again, you make it up, it's your project. In a question, they would give you what the height equals. The one on the left here looks like they chose equilateral triangles. So again, you would have to have the rule memorized, which of course we all do because the exam is in 15 days. And then lastly, here's somebody's project all together. I just thought it was kind of cute. They did these, it's the top view, but I think you can see that you've got equilateral triangles in there as well. So here's my goal. We're going to attempt a slice analysis for every slice that you are supposed to know, and we are doing setups only. I'm not going to evaluate them. So they said let R be the region bounded by the graph y equals sine of pi x, and y equals x cubed 4 minus x is shown in the figure above. Let your slices be perpendicular to the x-axis. Now let me be very clear. That doesn't mean you stop at the x-axis. It means your slice is perpendicular to the x-axis. So if the x-axis runs this way, clearly your slice is going to run this way. It doesn't mean stop at the x-axis, it's just saying which direction to go. So I'm going to draw in my slice, and just to verify, that line is perpendicular to the x-axis. Now, here's one catch you'll find on the AP. Notice they did not call it f of x and g of x. So no, you cannot call it f of x and g of x. You have to slowly write it out. So let's start with the absolute most basic slice analysis, the square. So what does that mean, the square? It literally means this is the base of a square and it is 3-dimensionally coming out at you. So picture you putting the thin piece of the square down and it's standing straight up, as you just saw in those pictures. So your slice basically represents the base. Perhaps if you're still stuck on these, you need to jot that down. Your slice is the base. So, how do you do a slice analysis? Well, it's extremely simple. You analyze the area. So you start with the shape and then you write the formula out. Well, what is the area of a square? Base times height. Now you analyze every piece of the formula. Well, you start with base. The base is upper minus lower. So now all you have to do is decipher who sine is. Does sine start up or does sine start down? Hopefully you know the sine curve starts up, so this one is the sine graph and this is the x cubed graph. So my upper minus lower is going to be my sine function minus my x cubed, and that represents my base. So I'm going to say it's the sine of pi x minus x cubed minus 4x. Now again, watch parentheses. Now, because it's a square, your common sense should say, what do I know about the height if I know the base? Well, you should know it's the exact same. Now that you've analyzed each piece in the formula, you write out the formula. So you analyze each piece and now you write it out. It is what you wrote for base times what you wrote for height. So technically, it's the sine of pi x minus x cubed minus 4x times itself. What would be a quick method to say that? Well, of course, most of you already wrote that down. I am just doing this for the few slow people that haven't caught on to this yet. I would say it's that quantity squared. So, how do you find the volume? Whatever you wrote for area, you literally just slap an integral around. Okay, I don't add in any special pi. This is not a disk or a washer. You literally write down what you wrote for area. And then you get your bounds correct. So if I look at my picture, it looks like my bounds are always going to go from 0 to 2. Alright, second slice analysis is the rectangle, where the height equals half the base. So again, let me get you started, and then I'll let you finish. You start with the formula. Again, this is how a slice analysis works. Area equals, it's a rectangle, you should know the formula. Base times height. Then you write down, you analyze each piece. Well, you have a B and an H. So the B should be obvious. It's the upper minus lower. The height, if it's a rectangle, there has to be a key. The key says it's half the base. Once you've got that plugged in, get your area and your volume. Pause it, see what you've got. Pause it. Alright, since you can't fast forward, I wrote all my steps out. Take a moment to kind of pause it and see if you've got all of them there. If you don't, if you're not sure where something came from, you know how to find me. Alright, let's get the next one in there, the semicircle. Alright, so what is the formula for a semicircle? Well, again, area equals, not the whole circle, semi meaning half, pi r squared. Now there's one catch to this. When you go to analyze each piece, in that picture, when you do your upper minus lower, and you picture a semicircle, that upper minus lower is not the radius. It's actually the what of the circle. Hopefully you've said it. It's the diameter. So you actually have to start with diameter here. There is no base or height in this formula, so I'm not using B and H, but you do have to start with a diameter. And then you obviously need the letter R for radius, and those are the only two variables you need. And then your area and volume. So my diameter is that sine of pi x minus my, what was it, x to the fourth minus, or x cubed minus 4x. Okay, now be smart. A radius is how much of a diameter? Well, it's half of whatever I wrote for diameter. Okay, now again, be smart. Start with your area formula. 1/2 pi radius squared. So I'm going to go 1/2 pi, and I'm going to take whatever I wrote down for radius and square it. So I wrote down this. So I have to put that in its place. 1/2 sine of pi x minus x cubed minus 4x. Now, some people just memorized the formula and there was a 1/8 involved. Where the heck did that come from? Well, think about this. When you square this piece, what does this 1/2 become? 1/2 times 1/2 becomes 1/4. And then I'm multiplying it by this 1/2, this 1/4, and this pi gets me 1/8 pi. And then I'm left with the sine of pi x minus the x cubed minus 4x, all of that squared. So my volume is the integral from 0 to 2 of whatever I wrote for my area. Alright, we're going to keep chugging. Our goal is to ace this. We've got 3 triangles you have to know. We have the isosceles right with the leg on the base. Now again, I don't think this is rocket science. Just slow down and draw the picture. Isosceles, 2 sides are equal. Right, make a right angle. Leg, put the leg on the base. Base meaning bottom. Bottom, right, isosceles, these two are the same. How obvious does that make it when you slow down and draw the picture? What do you know about the height and the base? Once you draw the picture, it's very clear that they are equal. So when I set up my formula, area equals 1/2 base times height, and I do my slice analysis, I have to have a B and an H and the area formula and the volume. Just slow down. Okay, I'm not going to work all these out, but I am going to kind of set them up. The next one is an isosceles right with the hypotenuse on the base. So again, I'm not saying memorize it, I'm saying draw the picture and it should be obvious. Isosceles, 2 sides are the same, hypotenuse has to be on the base, longer side has to be on the base. There's my right angle, therefore these are the 2 equal sides. Now you'll notice there's no height in this picture. You clearly have a base, but where the heck is the height? Height has to be a vertical straight line, so you have to drop in your own height. So, I've done all the math for you in previous videos, so hopefully by now you have known in your head that the height is equal to half the base. Again, if you want to see why that's true, go back and rewatch one of the videos where I explained it all, but the height is half the base. So when I do area equals 1/2 base times height, again I'm going to analyze my base, my height, my area, and my volume. And the height is half the base. The last one you have to be familiar with is the equilateral triangle. So again, draw it out for yourself. Equilateral meaning all these sides are equal. So again, this has a base. You have to draw in your own height and know the rule. If all three sides are equal, what is the rule? So again, the height is equal to radical 3 over 2 times the base. So when I go to do that slice analysis, area equals 1/2 base times height. Analyze your base, upper minus lower. Analyze your height, 1/2 upper minus lower. Your area is 1/2, whatever you wrote for your base times your height. And then get your volume from there. So I know this went a little extra long, but I tried to cover everything that we've talked about. And we're going to have some great practice tomorrow. So we'll see you then. Have a great night.